Number 13, predict the sign of delta S. Gas is the most disorderly. On this side of the reaction, we have 25 moles of gas. On this side of the reaction, we have 16 plus 18, which is 34 moles of gas. So if the right side of the reaction is more disordered, over the course of the reaction, entropy increased. Okay. On this side, we have aqueous on the left and solid on the right. Aqueous is more disordered, so over the course of the reaction, we have a decrease in chaos. While we're here, I'm going to do number 14. I'm given delta H and I'm given delta S, and I'm asked to find delta G. I'm going to use this formula. Notice that right now, those are not in matching units, so I need to make them match. So I'm going to change that to 5,500. Temperature is 298. Delta S is -25. So 5,500 plus 298 times 25 gives me 12,950 joules. This is positive. And since this is positive, it is not favored. This question asks, is it driven by enthalpy, entropy, both, or neither? I realize you haven't been asked this before. It's not a difficult thing, though. It is driven by enthalpy if we have a negative delta H. It's driven by entropy if we have a positive delta S. This reaction has neither of those things, therefore, it is driven by neither one. This next question isn't asking me to do that, but if I look here, this one has a positive and a positive. So we would say it's not driven by enthalpy. It is driven by entropy. All right. I'm going to do number 15 also while I'm here. Actually, I think I'm doing all the delta G ones together. Same concept as before. 144,000 minus T delta S. 144,123 minus 298 times 119. Gives me 108,538 joules per mole. Not favored at this temperature. So I need to decide the range of temperatures. Because I have a positive delta H and a positive delta S, it's going to be favored at high temps. I need to figure out what that threshold temperature is. So the way we do that is we use the same formula, but we set delta G equal to 0 and solve for T. So 144,000 divided by 119 tells me that my threshold temperature where this reaction shifts from not favorable to favorable is at 1210 Kelvin. Because it is favored at high temperatures, it would be when the temperature is greater than 1210 Kelvin would be the range of temperatures over which it's favorable. Okay, one more here. This one, I don't care what the reaction is. Doesn't matter. I have a K value. I need delta G. The R we're using is 8.314. The temperature is 298. ln 1.7 times 10 to the -6 will equal delta G. 298 times ln 1.7 e -6. You're going to have to put units on your answer. The reason I'm having you do it here is if I were to give you the reverse problem, which is equally likely on a test, if I give you this, you need to be able to solve for K. Delta G needs to be in the correct units here. It needs to be in joules per mole. I'm likely going to give you kilojoules per mole, which means you have to make sure to convert it or you're not going to get the correct K. If you're having trouble with this kind of math, either the forward or the reverse, like we did in class, speak up. Thank you.